Bismillahirrahmanirrahim. Today we are going to start chapter number 4, that is requirement elicitation. So outline of lecture is first we will discuss some concepts in requirement elicitation. Then we will discuss various activities involved in requirement elicitation. Software lifecycle. What is software lifecycle? So it is basically a set of activities and their relationships to each other to support the development of a software system. So typical questions about software lifecycle is: which activities should I select for software project? What are the dependencies between them? How should I schedule the activities? Which activities should occur in parallel? Which activities should occur one after another? What is the result of an activity? So next is the activities of software lifecycle. As you know these activities before also. So activities are requirement elicitation, then analysis, then design, then object design, implementation, and testing. So each activity produces one or more models. For example, as a result of requirement analysis, requirement elicitation and analysis SRS will be produced. So as a result of system design, design document containing the UML diagrams will be produced. So requirement elicitation is a very challenging activity. Why? Because it requires communication or collaboration of people from different backgrounds. For example, user has knowledge of application domain and developer has knowledge of solution domain. So in other words, developer has knowledge of implementation. So in order to bridge the gap between the user and the developer, various techniques are used, like scenarios, like use cases. So that's why requirement elicitation is a challenging activity, because it requires collaboration of people from different backgrounds. System specification versus analysis model. So what are these models? So both model focus on the requirements from the user point of view. For example, the system functionality, the interaction between the user and the system, the errors that the system can detect and handle, and the environmental conditions in which the system functions are part of the requirements. So requirement specification or system specification is structured and formalized during analysis to produce analysis model. So both requirement specification and analysis model represent the same information. They differ only in the language, that requirement specification uses natural language, while analysis model uses formal or semi-formal notation like graphical language UML. So the requirement specification supports the communication with the client. The requirement specification support communication with users. The analysis model support communication among developers. They are both models of the system. So they represent same aspects of the system. So requirement elicitation and analysis can occur concurrently and iteratively. So as you can see from the figure, So the requirement specification supports communication with client, and the analysis models support communication among developers. They represent the same information but differ in the language and notation they use. So next is requirement elicitation concepts. I am going to discuss various concepts in requirement elicitation. First is functional requirement, non-functional, completeness, consistency, clarity and correctness, realism, verifiability and traceability, and greenfield engineering, re-engineering and interface engineering. So first of all is functional requirements. So functional requirements describe the interactions between the system and its environment independent from implementation. So for example, an arena, which is the case study in your book, arena operator should be able to define a new game. Fine. So functional requirement define those actions and functions that the system can execute. So these are the functional requirements of another case study, that is sat watch. So the functional requirement is sat watch is a wristwatch that displays the time, that it displayed time based on its current location. So in the same way, sat watch determines its location using GPS satellite, and as such suffers from the same limitations as all other GPS devices. So these are the functional requirements of sat watch are given in this figure. Next is the non-functional requirements. So non-functional requirements describe the aspects of the system that are not directly related to functional behavior of the system. So the FERPS plus model used by unified process provides some categories of non-functional requirements. So let us discuss FERPS plus model used by unified process. FERPS requirement model. In the unified process, requirements are categorized according to FERPS plus model. This F indicates functional, U indicates usability, R reliability, P performance, and S supportability. And this plus indicates additional categories of requirements. So F functional requirements, that includes features and capabilities your system will perform. Usability is is how easy it is to learn the system, to prepare, how easily the system will get inputs and interpret outputs, how easy it is to use. It includes human factors, that if you are developing a game for fun, so is it really providing fun to the user. It also includes the scope of online help and the level of user documentation. So the aesthetics factor also comes under usability. So how consistent is the user interface. So next is the reliability. So reliability is the ability of a system to perform its required functions without failure. So reliability includes, for example, an acceptable mean time to failure. So how less frequently it fails. So it includes robustness, which is the degree to which a system or component can function correctly in presence of invalid inputs. And safety, which is a measure of absence of catastrophic consequences in the environment, how safe it is to use the system. Then performance, it includes response time, which is how quickly the user is reacting to how quickly the system is reacting to user input. And throughput is how much work the system can accomplish within a specified amount of time. Accuracy, and then availability, which is a degree to which a system is operational and accessible whenever it is required. So next is supportability. So supportability is concerned with the is how easily is to change the system after it is deployed. So it includes adaptability, which is the ability to change the system with additional application domain concepts. And the ISO 9126 standard on software quality replaces this category of supportability with maintainability and portability. And maintainability is what is the ability to change the system to deal with new technology. Fine, if the new technology comes, how easy it is to change the system to cope with new technology. And portability is the ease with which a system can be transferred from one hardware or software to another. So the plus indicates additional categories. So this includes implementation, so which includes resource limitation, the programming languages used, or hardware platforms. So what are the constraints on the implementation of the system? That this tool you must use, this hardware you must use. Interface, next is interface, are constraints imposed by external system. For example, if your system has to interact with a legacy system, that what constraints legacy system is has imposed on your system. So operating requirements, which are constraints on the administration and management of the system. So then packaging requirement are constrained on the actual delivery of the system. And then legal requirements are concerned with licensing, regulation, and certification type of issues. Like if you are developing a software, then it should be according to some act, some particular act of the government. So in this figure describes some quality requirements and some constraints for SAT watch case study. Like as the SAT watch has no buttons, no software faults requiring the resetting of the watch should occur. This comes under reliability requirement. So in the same way, response time etc will be under performance requirements. So SAT watch should display the correct time zone within 5 minutes and within 100th second over 5 years. So this indicates performance requirements, and in all 24 time zones. So this indicates performance requirements. So here will be written using Java. This indicates implementation requirements and complies with the physical, electrical, and software interfaces defined by Webify Watch API. So this is external system. So it must this sat watch must comply with it. This is interface requirement. Requirement elicitation concepts. So requirements are continuously validated with client and the user. So requirement validation involves checking that the specification is complete, consistent, unambiguous, and correct. So requirement validation criteria include correctness. So correctness is what? If the requirement represents accurately the system that the client needs and the developer intend to build. So correctness is if the requirement represent the client view accurately and should not mention unintended features. An example of it is car rental prices shall show all applicable taxes, including 6% state tax. Now, this state tax vary from state to state. So the tax depends on the state. So the provided 6% figure is incorrect. So this is an example of, you can say, incorrect requirement. So because the tax percentage varies from state to state. So another criteria is completeness. So if all possible scenarios through the system are described, including the exceptional behavior. So in short, all features of interest are described by requirements, then it is called complete requirement. So example of it is a destination country does not need to be displayed for flights within the US. So if the flight is within US, the destination country should not be displayed. And requirement 2 states that for overseas flights the system shall display destination country. Now what about Canada and Mexico? They are neither within US nor they are overseas. So what will happen if the destination country is Canada or Mexico? So that scenario is not mentioned. So this is about completeness. So requirement elicitation concepts is next is consistency. So consistency is what? That no two requirements contradict with each other. For example, requirement 1 states that dates shall be displayed in this format, and another requirement of the same system states that dates shall be displayed in this format. So these requirements are contradicting with each other. So such requirement should not be there. Unambiguous, if requirement cannot be interpreted in two different or mutually exclusive ways. So for example, the system shall be implemented using ASP. Now different users can interpret ASP in different ways. So such acronyms should be clearly defined. The correct version is the system shall be implemented using active server pages. Another requirement states that on the stored flight screen the user only view one record. Now does this means that the user can only view, not delete or update, or does it mean that the user can only view one record? Fine. So there is a ambiguity here. Can only view, not delete nor update, or can only view one record, not two or three. So and the correct version of the requirement is on the stored flight screen the system shall display, instead of you display only one flight. So it means only one flight. So next is three more desirable properties of a requirement specification are that requirement must be realistic, verifiable and traceable. So realism means the requirement must be implemented within constraints. It must be possible. It must be realistic. So an example of unrealistic requirement can be the system shall have a natural language interface that will understand commands given in English language. Now, this requirement may not be feasible within a short span or may not be possible within a short span of development time. So, this can be an example of unrealistic requirement. So, next is verifiability. So, this means that testers should be able to verify whether the requirement is implemented correctly. Verifiability means the requirement should be testable. So, examples of non verifiable requirements the product shall have a good user interface. Now, here, good is not defined. And another example is the product shall be error free. So, error free, 100% error free is not possible as it requires large amount of resources to establish. So, some adjectives like robust, safe, accurate, some adverbs like quickly, safely, timely, and some etc. These type of words should not be there in requirements. An example of it is the search for example, the search facility should allow the user to find a reservation based on last name, date, etc. Now, etc, how the tester will test etc. So such type of words should not be there in requirements. So verifiability means that the requirement should be testable. So another aspect is traceability. So each system function can be traced to a corresponding set of functional requirements, and traceability is critical for developing tests and for evaluating changes. So requirement specification is traceable if the requirement can be traced throughout the software development to its corresponding system functions. And if each system function can be traced back to its corresponding set of requirements. In short, the traceability means the requirement should be traced back and forth. So, uh, if the requirements if the requirement is atomic and has a unique ID, it is usually traceable. So next is requirement elicitation activities can be classified into three categories. So first is greenfield engineering. So what is it? In this, development starts from scratch. So no prior system exists. So the requirements are extracted from end users and client. So greenfield engineering project is triggered by a user need or the creation of a new market. So example is develop a game from scratch. Next is re-engineering. As the name indicates, is the redesign and re-implementation of an existing system triggered by technology enablers or business processes. So in this, the essential purpose of the system remains same. So the requirements of the new system are extracted from the existing system. For example, re-engineering of an existing game. Third is interface engineering. So it is the redesign of the user interface of an existing system, like legacy system. So triggered by technology enablers or new market needs. So example of it is interface, new interface of an existing game.